Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we're going to talk about connected rates of change. So, this is basically the second topic and the last topic on this chapter, chapter 10, on further differentiation. In this topic, we're going to use exactly that we did before on differentiation, which we called it implicit differentiation. So as we did before on the previous video, we did two types. We got that we have two types of differentiation: implicit differentiation and explicit. Explicit when the y is given in terms of x, and the implicit when not one of them is a subject and the other one is a variable, or if not one of them is in terms of the other. So we're going to talk today about the same idea, but we're going to use shapes now. So that's why we call this topic as connected rates of change. Let's start with the first question. So basically this is exercise 10b into page 213 on the textbook. Question number 1b, dv by dt, which means when you differentiate v respecting to t. I think we spoke about this point before when we did the chain rule on chapter 5. On the chain rule, I told you we can differentiate any function or any variable respecting to another variable using many of different variables, infinity number of variables. See, dv by dy times dr by dt. So basically to reach to dv by dt, we have to split the dv once respecting to r and then r respecting to t. So here we have to write dr. Second one, dy by dt. See, this is dy at the beginning and you end with the dt. So between them, you can write any number of variables. dy respecting to a and then a respecting to it. So we can know that from the next term. So it's dc, say dA by dc, which means a respecting to c, and then c respecting to t. That's it. Let's apply these two rules here. The radius, this is question number 3, the radius of a circle is increasing at 3 centimeters per second. So the meaning of rate of change, it could be increased or decreased. In case of increase, it has to take positive. In case of decrease, we have to write negative. But remember, we couldn't use any negative value with any type of measurement. So this value is dr by dt. How do you know that? Because the question said radius is increasing. So radius means r, and increasing means d by dt, because it's increasing or decreasing respecting to time. So this is dr by dt. So for example, if the question said the volume is increasing at, so it's dv by dt. The area is increasing or decreasing at, so it's dA by dt, and so on. Now find the rate at which the circumference is increasing, which means find dc by dt. Why c? Because c stands for circumference and r is equal to 5. So for the circle, the circumference of the circle is 2 pi r. How many unknowns you have in this equation? It's two unknowns, c and r. In explicit differentiation, we can differentiate c respecting to r. But in implicit, we should add one more variable, which is time respecting to time. So we differentiate both sides respecting to t. So dc by dt equals 2 pi is a constant. So you never change anything with the constant. For example, derivative of 2x squared. You keep the 2 and you differentiate only the x squared, which is 2x. And then 2 times 2 will give you 4, then it's 4x. So you keep the 2 pi as it is, and then differentiation of r is 1, but because you differentiate respecting to t, So it has to be dr by dt. Now start to replace the values. dr by dt is given to you in the question as what? 3. So dc by dt is equal to pi times 3, which is equal to 6 pi centimeters per second. B. Find the rate at which the area is increasing when the circumference is 20 pi. So it's required to find dA by dt. Rate at which area is A, is increasing when the circumference is 20 pi. So C is given as 20 pi. What are you supposed to do? We don't have the radius. So you're going to say that we have a radius already in part A, but actually these two questions are completely different. The only thing which is common for these two is the rate of change of the radius, which is dr by dt. But into this case you have a radius, and in this case you have another radius. So you're supposed to find the radius first using the circumference. Again, circumference is 2 pi r. So 20 pi equals 2 pi r. Pi, cancel pi because you divide both sides by pi, and r is equal to 20 over 2, which is equal to 10 centimeters. We got the radius. Then, now you have to work in area. Area of the circle is pi r squared. Start to differentiate it respecting to time, dA by dt. Keep the pi as it is, and derivative of r squared is 2r times dr by dt. Now replace the value of the radius. You got the radius as 10. This is the radius. And dr by dt is given to you in the question as what? 3. 3 times 10 times 2, 60 pi centimeters squared, centimeters squared per second. Why? Because this is area. So which means the rate of change of the volume will be centimeters cubed per second. Question number 4. A cone has height 6 centimeters. The radius of the cone is increasing at. So basically the spot, the rate of change of the radius, which means dr by dt. So let's write it here. dr by dt is equal to 5 centimeters per second. You know the cone has radius, height. Radius is 4. Height is 6. Find the rate of change of the volume, which means find dV by dt when the radius is 4. So this is the radius and this is the height. The formula of the volume of the cone is 1 over 3 pi r squared h. The formula will be given to you in the final exam. V respecting to r and h, but you have to make one of them as a constant. Why you have to make that? Because the question asks you to find the rate of change of the volume, and the change that you have only will be in the radius. I know you'll have a change even in the height, but height still constant. So what you're supposed to do, we're going to differentiate both sides respecting to t. 1 over 3 pi h. These three terms are constants. Now we're going to differentiate r squared. Differentiation of r squared is 2r times dr by dt equals to 1 over 3 pi, height 6, radius 2 times radius, which is 4, and dr by dt is 5. You just replace it there. 5 times 4 times 2 times 6 over 3. Basically 6 divided by 3 is equal to 2. 2 by 2 by 20 is equal to 80 pi centimeters cubed per second. Question number 6. A sphere has radius r. The surface area of the sphere is 4 pi r squared. Area 4 pi r squared. This is the formula. Find the rate of change of the area, which means find dr by dt. It's required to find dr by dt when the radius is 2, so r is given as 2, and the rate of change of the radius, which means dr by dt is equal to 1 centimeters per second. It's required to find the rate of change of the area. So rate of change, which means dA by dt. It's very simple. You have to differentiate both sides respecting to t. dA by dt equals 2. Keep the 4 pi as it is because that's a constant. And differentiation of r squared is 2r times dr by dt. 4 times 2 is 8 pi. Radius is 2. dr by dt is 1. Then the answer is 16 pi centimeters squared per second. Question 7. If y, this is not one of the shapes, but it has the same idea. You have y in terms of x. So what do you call this? We call it explicit. Y in terms of x. But what you're going to do is implicit because you differentiate y respecting to a variable which is not given to you, which is t. Find dy by dt when x is equal to 2, given that dx by dt is equal to 2. So let's differentiate both sides respecting to t. dy by dt equals 2. This is chain rule, so move the 3 before the bracket. X squared minus 3x power of 2 multiplying by derivative of what do you have inside? It's 2x minus 3 multiplying by dx by dt because you differentiate respecting to t. Start to replace 3. What is the value of the x? It's 2. This is the x value. So 2 squared minus 3 by 2 power of 2. Then 2 by 2 minus 3 and dx by dt is equal to 2. It's given to you in the question. Now 3, this is 4 minus 6 is negative 2 squared, and 4 minus 3 is 1 times 2. 3 times 4 times 1 times 2, so 12 times 2 is 24, and there is no unit because the question in this topic, question number 12, a hollowed right circular has height 18 centimeters. This is the cone. A hollowed right circular cone, I missed this word, cone, has height 18, so this is 18, and base radius is 12, so this is h and this is r. Its held vertex downwards beneath a tap leaking at rate of 2 centimeters cube per second. So basically from the unit we can recognize that changing of the volume respecting to time. So dV by dt equals 2 centimeters cubed per second. Find the rate of rise of water level, which means find dr by dt when the depth is representing the h. Now this is the cone, 12 is the radius, height is 18. Now the new height when you fill the cone now is reaching to 6. So find the rate of change of level of the rise, or the rate of rise of water level, which means find dr by dt. Now r is not given. If you remember, you studied in grade 10 similarity of triangles. Similarity, angles are equal and the sides are proportional, which means r over 12 is equal to 6 over 18. So we're supposed to find the new radius when the depth is 6. So what you're supposed to do, you just do cross multiplying. This is r over 12 equals to 1 over 3. So 3r is equal to 12. You do cross multiplying, then r is equal to 4. R is equal to 4. Now we have to use the formula of the volume of cone. So volume of the cone is 1 over 3 pi r squared h. Yes. Now differentiate both sides respecting to t. Now we know that h is a constant, so you keep 1 over 3 pi h times 2r times dr by dt. Now this is 2, then 1 over 3 pi. Height into this case is 6. Now the new radius is 4, and then dr by dt, which is required to find. 2 cancel 2. That's like you divide both sides by 2. Then 6 divided by 3 is 2. 2 times 4 is 8. So 1 equals to 8 pi times dr by dt. Then dr by dt is 1 over 8 pi centimeters per second.